Hello, welcome to my YouTube channel. In today's video, we're going to look at integration by substitutions. And when you come across questions, how can you know when to use substitution method? When you come across integration questions, when you see integral of the form this and this, when you see it in this form or this form, you make use of substitution method. Don't be confused. I'm going to break it down for you, what this means and what this means. What does this f of x mean? This f of x is also the same thing as y. You know, in integrations or differentiations, let's say you are given y equals to, let's say, 2x raised to the power of 2, and you ask to find y dx. Now, let me tell you that this y, it depends on the value of what? X here. Let's say the value of x is 2. When you are done with the simplifications, it will give you the value of y. When you change this value of x to be 3, the value of y will also change. When you change it to be 10, the value of y will also do what? Change. What that tells you is that this y is a function of what? X. It depends on the value of what? This x. That is why you can also write this y as what? F of x. What it tells you is that y is a function of what? X, as I've explained earlier here. So this f of x, since you say y is equals to this, and y is also equals to what? F of x. You can also say f of x is equals to what? This. I hope you are getting it. So y is a function of what? X. Y is a function of what? X. It depends on the value of x. So in the questions, let's say you're given f of x. Take note that it's also the same thing as the value of what? Y. Okay, now let's say you're given this kind of questions and you have to find the y, the x. Now, may I tell you that I want to let you know that the y, the x is also the same thing as what? Y prime. Now, you know, I told you that y is equals to f of x. Now, what if I have y prime? Y prime will also be the same thing as what? F of x prime. I hope you are getting it. So, the y dx is the same thing as y prime. At times in a question, you may be given that if y equals to this, find y prime. Find y prime. So, what they are trying to tell you is that y prime is also the same thing as the y dx. And the y dx is also the same thing as also what? Y prime is also the same thing as f of x prime. Let's take note of that. So, what this means is that, let's say you are given a function of x. After you have done with its integrations, you know, it will change to f of x. It will change to f of x prime. Yes. So what this tells you that if you differentiate the denominator here, if it give you, you know, when you differentiate f of x, it will give you f of x prime. So what this tells you is that if you differentiate the numerator and it give you what is the denominator, and it give you what is on the numerator here, you make use of substitution method. Now, if you should look at this as a case study, if you notice that if you differentiate the denominator here, it will give you exactly what is on the what? The numerator. Then at that point, you make use of what? Substitution method. Okay, now let me explain what this tells you, what this means. Now, as I've said that y is also a function of what? X. Let's say you differentiate what is here. You know, when you differentiate f of x, it will give you f of x prime. So what this tells you is that when you differentiate what is here and it gives you what is also here, then you make use of what? Substitution method. Look at this numbers, this as a case study. If you differentiate this, you will notice that if you differentiate this using general method, it will also give you what? This. It will give you this. So at that point, you make use of substitution method. Now, let's solve example. Let's solve the following examples. Question number 1. I hope you are getting it. Don't forget to subscribe, like, and comment. So let's solve example 1. You're given that integral 2x plus 3 over x raised to the power of 2 plus 3 minus 5 dx. And one thing very interesting about this video is that I will teach you, I will explain to details, and I will also give you short method. You can easily get it, especially for those of you come across this kind of questions in objective in such a way that you will not spend more than 5 seconds when you come across this kind of questions. I'll give you the short method and also analyze everything for you. For those of you that come across it in let's say theoretical aspect, So since as I've said that if you differentiate what is here and it will give you what is here, then sorry, here is x. Sorry, here is x. X is here. Minus 5. X is here. So whenever you differentiate this and give you this, make use of substitution reaction. Substitution method, as I've said. Substitution method. So let's take what is here to be the value of what? U. Let's say u equals to x raised to the power of 2 plus 3x minus 5. Now u is in respect to what? X. So I will now have what? If I differentiate u with respect to x, it will give me what? The u over the what? Over the x. If I don't want to say differentiate the u dx, what can I also say? I can also say find u prime. Just take note of that. So if you differentiate the u with respect to the x, it will give you what? Now using general method, you can watch my video on general method of differentiation for you to have a clear understanding. So you use these two to multiply, subtract 1 from it to give you 2x. This will give you plus 3. Now you have gotten the u dx to be this. Now coming back to this, we have integral 2x plus 3 all over. You have represented everything here to be what? To be u, the x. Now you can't integrate like this. You can't integrate because this is u, this is x. Now I want to replace this dx. You will understand this better as we are going. I want to replace this dx. So I will make the x subject to the formula here. Now if I should make the x subject to the formula, I will have let's say I make the x subject to the formula. We have, we have the u over the x equals to 2x plus 3. So if I make the x subject to the formula, I will cross multiply. And when I cross multiply, this is also the same thing as over 1. It's also the same thing as over 1. So the u times the 1, it will give you the u equals to this times the x, that is 2x plus 3, everything into brackets, the x. Now mind you that we are making the x subject to the formula, so I will divide by the coefficient of the x. What is the coefficient of the x? Coefficient of the x means everything beside the x, and we have 2x plus what? 3. We have 2x plus 3. Mind you, we are dividing both sides by the coefficient, which is 2x plus 3. So in this, we cancel this. We are now left with what? The x. Now we now have the x equals to what? Du over what? Over 2x plus 3. So we have gotten the value of the x to be this. Now I will now substitute it into this equation, into this. Now let me write the value of the value of the x, which is equal to the, let me write it here because I want to clean this part. So we have the x equals to the u over the u all over 2x plus 3. So I want to erase it. I hope we have put them down. So let me erase it. Now I've gotten the value of the x to be this. Now I want to replace this dx. As I've said, I will explain now. I will explain at this point the reason why I want to replace this dx. So let me bring this. We have 2x plus 3 all over u. Let's say times dx. Let me just say times. At times you can use dots in mathematics. It still means multiplications. But let me just use times. The dx. Dx is equal to what? The u over what? Over 2x plus 3. So you can see that this is 2x plus 3 and this is also 2x plus 3, so they can cancel each other. So this cancel this, we are not left with integral, this cancel this, we are not left with what? The u over u. And you know that you can also rewrite this as what? Now you can also write this as 1 over u du. Now you can see the reason why I changed this to this is because now you have u and you have the u. Let's say here is the x. You can integrate u with respect to the x because u is different from x. It is when you are dealing with partial integrations, or when you are dealing with partial differentiations, you will get to understand there's a difference between the, let's say you have u du, u du is different from u partial derivative of the u. Sorry, yeah, let's say you have u dx is different from partial derivative of the x. This is different when you come across something like this in mathematics. This or this, they are different. We use this when dealing with partial differentiation or partial integrations. No, you can watch my video on that for you to have a clear understanding. So now if you should integrate 1 over u, you know, we can now integrate because this u and this also u, so we can integrate. 1 over u will give you ln u. Let's say, what if I give you 1 over x? What will it give you? It will give you ln x. Mind you, when integrating, you have to include your constant. What if I give you 1 over y? 1 over y. What will it give you? It will give you what? Ln y. Make sure you include your what? Your constant. So if I should integrate this, it will give me what? Ln u plus what? C. Now recall that you represented u to be what? To be this. Now let me substitute this, which is the value of u, back to the position here. So I will now have ln into bracket. What is u? U is equals to this. We have x raised to the power of 2 plus 3x minus 5, and put your constant too. Your constant. So that's our final answer. Now, as I've said that, I will also teach you the short way you can get it. And what is the short way? After you have been able to discover that here you can use what is it called? You can use substitution method. So you don't need to waste your time, especially in objective. Just take the ln of the denominator. Take the ln of the denominator. And what is the denominator? We have what? It will be ln of the denominator. And the denominator is what? Is x raised to the power of 2 plus 3x minus 5. Don't forget to put your what? Your constant. No, it's not at the top, but don't forget to put your constant. Put your constant. So that's just it. Very simple. So let's solve question number 2. You are asked to integrate cot x dx. This is very simple. You know that cot x is the same thing as what? It's the same thing as cos x over what? Sin x. So just put the x here. This cot x is the same thing as cos x over sin x. Of course, you know that tan, let's say tan x is the same thing as what? Sin over what? Over cos. So y cot is inverse of tan. Cot is inverse of tan. So it is not sin over cos, but rather what? Cos over what? Over sin. So now if you look at this, now how will you know whether you can use substitution method? If you differentiate sin, as I've said in that question number 1, whenever you differentiate the denominator, if it gives you exactly what is on the numerator, you can use substitution what? Method. Now if you differentiate this sin, you know, whenever you differentiate sin, it will give you what? It will give you cos. So you can use what? Substitution method. You can use substitution method. So you just say let u equals to what? The denominator. And the denominator is what? Sin x. So you can just say let u equals to sin x. Okay. So you can, this u is in respect to what? X. So you can say the x equals to what? Whenever you differentiate sin x, it will give you what? Cos x. Okay. Now this is x. Now I want to make the x, sorry, this is the x. I want to make the x here subject to the formula. So what I'm going to do is that I will cross multiply. If I cross multiply, this will multiply this will multiply this. So the u times 1 will still give you the u equals to cos x times the x, to give you the x. Now mind you that I'm making the x subject to the formula dx. This is what I'm making subject to the formula. So I will divide both sides by the coefficient of the x. And what is the coefficient of the x? The coefficient of the x is what? Cos x. So I'll divide both sides by cos x. Divide both sides by cos x. So dx equals to du over cos x. All right. So now I want to substitute this dx back to our normal question. So we have cos x over, mind you that we have replaced this sine x to be what? To be u. Times dx. What's our dx? From this place, we have dx equals to du over cos x. Okay? Now, if you look at it, you see that this cos x can cancel this cos x. We are left with 1 times the u, it will give you the u, all over u times 1, it will give you u. So, if you have to, you can also rewrite this as integral 1 over u the u. Of course, you know that if you want to multiply the u, it will still give you the u, all over u. So, it's still the same. And whenever you integrate 1 over u, it will give you what? Ln u. Just include your constants. See. But recall that u equals to what? Equals to sine x. So you can, if you substitute sine x into the value of u, we have ln sine x plus what? Plus c. That is our final answer. That is our final answer for that. And let me explain this. Let me give you the short method again. As I've said that if after you have noticed that you can use substitution method, don't waste your time. For those of you doing this kind of questions in objective, don't waste your time. Since you know that whenever you differentiate numerator, it will give you exactly, whenever you differentiate denominator here, it will give you exactly what is in numerator. Just take the ln of the denominator and you are done. Just take the ln and what is the denominator? Sine x. Just take the ln. Therefore, integration, if you find the integration, it will give you the ln of this. That is the ln of sine x. Just put your constant because you are dealing with integrations. Don't waste your time. Don't waste your time. You see that in less than 3 seconds, you have gotten your answer. In fact, 1 second, you already know your answer. So let's solve question number 3. Let's solve question number 3. Let me just give you the analysis of this. You can solve question number 3. You can solve question number 3. Drop it on the comments. So I want to know if you can solve it. Just drop it there. I will prepare a video for that special, because I think number 3 is very close to this. So let me just explain it for you. This is the same thing as this tan x dx. You know, tan x is the same thing as sine x over what? Over cos x. Just don't forget to put the x. Don't worry. Okay, let me solve it. Let me solve it for you guys. Let me solve it. So you know that if you differentiate this, it will give you this. Although it will have negative sign, but it will still give you this. Take note of that. If you differentiate this, it will still give you this, but just like it will have a negative sign. So just take the denominator to be your what? U. U equals to cos x. So if you differentiate u with respect to x, it will give you the u dx equals to, if you differentiate cos x, listen, if you differentiate cos x, it will give you what? Minus sine x. Yes, it will give you minus sine x. So if you want to make the x subject to the formula here, the u equals to minus, if you cross multiply, this is like over 1. Minus sine x dx. So if you make the x subject to the formula, you divide by the coefficient. What I mean by coefficient is that everything beside the x here. So and the coefficient of the x by the coefficient of the x. So minus sine x minus sine x. So this cancel this. Dx equals to, bringing this minus here, we have minus the u over sine x. Now, if you substitute the x back to this equation, we have integral sine x all over. Mind you, you have represented say cos x to be what? To be u. So put u. The x is what? The u over sine theta. Sorry, minus the u over sine theta times minus the u over sine, sorry, not sine theta, sine x. So you will see that this cancel this. We are left with 1 times minus the u is times. Don't put 1 minus the u. No, you are dealing with multiplications. So 1 times minus the u, it will still give you, or you can put the minus aside. So you just say integral 1 If you multiply 1 times the u is the u. So just put the negative sign there. Minus the u over u. So you can also rewrite this as this. Integral minus 1 over u du. Of course, you know that if you use this minus 1 to multiply the u, it will still give you what? Minus the u. So if you take the ln of 1 over u, just bring the what is it called? The negative outside. You have minus ln into brackets u. You can bring the minus outside. You can bring it outside. So we have, if you bring the minus outside, you can bring it outside. If you bring it outside, so if you now integrate 1 over u, it will give you what? Ln u. Don't forget to include your constants. C. So recall that u is equals to what? U is equals to this. So bringing this back into the position of u, we have minus ln cos x plus c. That is your final answer. That is your final answer. Okay. So the short way you can get this is that now you know that whenever you differentiate this, it will give you this. But there will be what? It will give you, if you differentiate it, it will not give you sine, although it will give you sine x, but it will be negative. So just take the ln of this and put that negative there. Put the negative first. Take the ln of this cos x. You know the one we have been doing before? The one we have been doing before, it will give you positive. It will not give you negative. But because this will give you negative sign, not sine. So take the ln of this, just put the negative outside. Put it here. So that is the short way you can get that. So let's solve question sorry, this is a number 2, number 3, this is number 4, this is number 4, and this is the number 5. So let's solve question number 4. Let's solve question number 4. X over 1 plus sine x. So you may be looking at this question, you can be frustrated that this is too difficult. No, it's not difficult. You will still use substitution method. As I've said that whenever you differentiate this, so if you differentiate this, you know it will give you 0, right? Okay, so this is plus. If you differentiate sine, it will give you what? It will give you cos. So if you differentiate the denominator, it will give you what? Numerator. So you can use substitution method. It's very, very simple. So you can just say, let's u equals to what? The denominator. So you can say u equals to 1 plus sine x. So if you differentiate u with respect to x, the u over the x equals to what? This will give you 0. So if you differentiate sine x, it will give you cos x. So if you make the x out of the formula, first of all, you cross multiply. So the u equals to this times the x, the x times cos x, it will give you cos x dx. So you divide both sides by the coefficient of the x, which is cos x. Cos x over cos x. This cancels this. So the x equals to the u over cos x. All right. Okay. So you want to substitute the x, which is this, back to the normal question. So we have a integral cos x over, mind you that you have represented everything here to be what? To be u. So u times this dx, and the x is given to be what? The u over cos x. Okay, so this cos x cancel this cos x. We have an integral, the u, 1 times the u to give you the u over u. So you can write this as 1 over u, the u. So if you take the ln of 1 over u, it will give you ln u, it will give you ln u plus c. So if you substitute the value of u, because the value of u is what? Is this. So let's substitute 1 plus sine x into the value of u. We have ln, you can open brackets here, ln into this. 1 plus sine x plus c. That is our final answer. So in a short way, for those of you doing objective, let's say you are given this kind of question in objective, once you are able to determine that this, you use substitution method, just take the ln of the denominator. Don't waste your time. Just take the ln. Since you know that this, you use substitution method. Just take the lane of the denominator, don't waste your time. And the lane of the denominator, this is denominator, just take the lane. The lane will be, put the denominator there, 1 plus sine x. Just include your constant because you are dealing with integrations. Include your constant. See, so that is just it. That's the final side. Can't you see that it's still the same thing? It's the same. So let's the last question here. Question number 5. You will make use of this method. This method, you make use of this. If you differentiate this, okay, let me solve it. Let me solve it. So let's solve question number 5. And don't think it's very hard. It's also simple question. So if you observe this very well, you see that f of x, here is f of x, here is also f of x, but the difference is that this one has a prime. What this tells you is that if you differentiate this, it will give you this. You understand? If you differentiate this, it will become prime. So it will become prime. So if you differentiate this, it will give you this. So let's look at these questions. You will notice that if you differentiate this, it will give you what? This. So once you differentiate this, it can also give you this. You can make use of what? Substitution method. You can also make use of substitution method. So those are the two conditions you can make use of substitution method. In that first one I did there, I think I've actually erased it. In this form, when you have f prime of x all over f of x. Yes, you in this form and in this form, you make use of substitution method. So let's solve this. Let's solve this. Now, if you differentiate this, okay, let me write it here. Let me write it here. We have integral x raised to the power of 2 plus 7x minus 4 into brackets 2x plus 7 dx. So let's solve it. It's very simple. It's very, very simple. Question number 5. So this is it. So as I've said that if you differentiate this, if it gives you this, as I've said that these are the two conditions you make use of substitution method in this form, and I've done about 4 examples on this. So also if you see it in this form, that is, if you differentiate what is here, if it gives you what is here, the difference between this and this is this prime. What it says is that after you differentiate this, if it gives you this, so you can make use of substitution method. And if you look at this, if you differentiate this, if you use general method, this will give you, this 2 will multiply it, subtract 1, it will give you 2x, this will give you 2x. If you differentiate 7x, you can watch my video on general method of differentiation if you don't understand it. So it will give you plus 7. You will notice that this will become 0. This, it gives you exactly what is there, so you make use of substitution method. So let's continue. So you say take what is here to be what? To be u. Because you are differentiating this to give you this. So take what is here to be u. So let's just say let u equals to x squared plus 7x minus 4. Okay, that's good. So differentiating u with respect to x, it will give you the x equals to, if you differentiate this using general method, 2 times x, it will give you 2. Subtract 1 from it, it will give you 2x. Now you know that this one has a power, is the same thing as this x is the same thing as x raised to the power of 1. So if you use the 1 to multiply 7, it will give you 7. But here is 1 minus 1. 1 minus 1 will give you 0. So x raised to the power of 0, it will give you what? 1. Any variable or any number raised to the power of 0, it will give you 1. So this gives you 2x. So you know that this gives you 2x plus 7. So let's make the x subject to the formula here. Let's make the x subject to the formula. And firstly, to make the x subject to the formula, cross multiply first. Mind you that this will multiply everything. So you put this in brackets. So they give it the u equals to 2x plus 7. Everything to bracket dx, because you are multiplying everything here with what? With dx. So you are making the x subject to the formula. You divide both sides by everything beside it. That is the coefficient of the x. And the coefficient of the x is 2x plus 7. So divide both sides by 2x plus 7. Okay, 2x plus 7. This cancel this. You are left with the x equals to the u over 2x plus 7. All right. So let's substitute the u into this, and let's substitute the x into this. So here we have integral. Mind you that you have represented everything here, this side with what? With u. So you say u times what is here, which is 2x plus 7 times the x, and the x is what is the x? You know, we want to substitute for the x too. The x is equals to the u over 2x plus 7. That is the u over 2x plus 7. All right. So if you should look at this 2x plus 7 and this 2x plus 7, they can cancel each other. So this cancel this. We are not left with integral this u times the u to give you the u all over 1. Just leave it like that. It's all over 1. So when you integrate this, what will it give you? Since this is u and this is u, this is different from integral 1 over u, the u. So this will give you ln, but this will never give you ln. It will give you the normal method, like the general method of integration himself. You know, in integration himself, let's say you are asked to integrate x to the power of 7. You know, the x. So if you want to integrate in integration, you will add 1 to the power, then divide by everything here. You can watch my video. I've actually prepared a video on that. So you add 1 to the power. You know, in differentiation, you use this one to multiply it and subtract 1 from the power. But in integration, you add 1 to the power. So this will give you x raised to the power of 7 plus 1, because as I said, you add 1 to the power. You now divide by everything that is here. This will give you 7 plus 1. So this will give you x raised to the power of 8 over what? Over 8. So the same thing applicable to this. This has a power of what? 1. So you add 1 to the power while integrating. That is u raised to the power 1. It has 1 before as power. Plus 1 divided by everything that is here. Everything that is here. And that will be 1 plus 1. Make sure you include your what? Your constant. So this gives you, u 1 plus 1 will give you 2 all over 2 plus what? Plus c. And sorry, this 2, not u. 2. So if you substitute, recall that the u is equal to what? You represented u to be what? To be this. So let's substitute this back to the position of u here. We have mind you that is square. That is everything here, which is u. You know, everything here is u. So we put everything raised to the power of what? Square. So here we have x raised to the power of 2 plus 7x minus 4, everything over square divided by 2 plus your constant. That is our final answer. Please, if you find this video helpful, kindly subscribe, like, comment, share to your loved ones. Thank you.